Alright guys, today we're going to be looking at rational inequalities, and the way we're going to solve these is a lot like what we did for polynomial inequalities. There is going to be one difference though. So whenever we solved polynomial inequalities, the only points we needed to find were the x-intercepts, because that was the only point our graph could change from positive to negative. With rational inequalities though, we need to remember you also can switch from positive to negative at the vertical asymptotes. So what that means for us is we need to find vertical asymptotes, which is when the bottom is equal to 0, and we also need to find our x-intercepts, which is when the top is equal to 0. So we're going to solve these the same way. We're going to find those points, and we're going to mark them on a number line. So, for example, my vertical asymptote is at -2, and my x-intercept, when the top is equal to 0, is at 3. And then I'm just going to look at the sections that I have. This first section is everything to the left of -2. So if I pick a number to the left of -2, like a -5, if I plug that in, I get a negative number at the top divided by a negative number at the bottom. And a negative divided by a negative is going to work out to be positive. If I pick a number in that middle section, like 0, that would give me a negative number at top divided by a positive, which works out overall in that section to be negative. Then finally, I need to pick a number to the right of 3. So a number to the right of 3, anything bigger like 5, that would give me a positive number at the top divided by a positive. And any positive divided by a positive is positive. So now what I need to do, remember, is look at what my question's asking for. So this question is asking for me to find when this function is less than or equal to 0. So that means I'm looking for negative numbers, and my negative section is from -2 to 3. Then I just need to determine if I'm using parentheses or brackets. Now since it's less than or equal to, I need a bracket at 3. But one thing that makes this a little bit tougher than polynomial inequalities, I have to remember that -2 is actually an asymptote, which means no matter what, I'm not going to actually touch -2, because it's not a 0, it's an asymptote. So what we need to remember is that our vertical asymptotes will never be brackets. They will always be parentheses. So it's kind of like infinity. Infinity can never have a bracket, it can only have a parenthesis, because we'll never actually touch that vertical asymptote. Alright, the last thing I could possibly have to work on with rational inequalities would be if it's not equal to 0 already. Now we already talked about this before, where if it's not equal to 0, we need to set it equal to 0. And in order to do that, I would have to add 2 to both sides. So if I did that over here, the only way I could add 2 is with a common denominator. So what I need is to multiply the top and bottom of this fraction by x plus 2. So what that means I actually get is 2x plus 4 over x plus 2. And now that I have a common denominator, I can combine those together pretty simply. And now I can work this question out the same way I've been working it out. So I need to mark my x-intercepts and my vertical asymptotes on my line. So my x-intercept is going to be at -1/3. That's when the top equals 0. My vertical asymptote is when the bottom equals 0, which is -2. And I'm going to work this out the same way and find those sections. So my first section is when anything less than -2, and I'm going to plug it in to the function once I've added 2. So if I plug in a number left to -2, that's going to give me a negative divided by a negative, and that works out overall to be positive. So everything to the right of -2 is positive. That in between section would be something like -1. -1 would give me a negative divided by a positive, which works out to be negative. And everything to the right of -3, something like a 0 or a 1, it's going to give me a positive divided by a positive, which is positive. So now this question is asking for where my function is greater than 0, not equal to, so I'm going to have all parentheses here. It doesn't matter if it's a 0 or if it's an asymptote. So my final answer would be from -infinity to -2, and also from -1/3 to infinity.